Hello, my name is Zane Gourlay, and today I will explain what nodal analysis is and show a worked example. Nodal analysis is a mathematical method that is used to analyze circuits in terms of voltage drops between nodes in a circuit diagram. Nodal analysis is an essential method used in electrical engineering and electronics to analyze electrical circuits. It's particularly useful for analyzing complex circuits with multiple interconnected components, such as resistors, capacitors, inductors, voltage sources, and current sources. The steps of nodal analysis include identifying nodes, applying KCL and Ohm's law, solving equations, and calculating any other parameters. In this example, we will be finding VA to then solve for I1, I2, I3, and the voltage drop across all the resistors. By using KCL, which is the equation that the sum of all the currents entering and leaving a junction must be equal to 0, and Ohm's law of I equals V on R, as shown on the right, you can determine the value of VA, which is found to be 2.72 volts. The next step is to determine the voltage drop across all the resistors, and this is done by subtracting the input voltage into the resistor by VA, which is the voltage found at the node. By doing this, we find that the voltage drop across resistor 1 is 0.28 volts, across resistor 2 is 3.28 volts, and resistor 3 to be 2.7 volts, as VA is flowing in the opposite direction in comparison to V1 and V2. Then, by finding the voltage across the resistors, it is now possible to use Ohm's law of I equals V on R to determine the current. It is found that the current of I1 is 0.093 amps and the current of I2 to be 0.364 amps and I3 to be 0.453 amps. Lastly, to confirm you have done the right steps, you can use KCL to find the sum of all currents. We do this from the KCL equation of I3 minus I2 minus I1 equals 0. If the sum of all currents equals 0, you have done this correctly. Thank you all for watching this video on nodal analysis.